Hello again, Econ 160, and welcome back to another video lecture. Today we will be talking about a concept known as elasticity. So in the last two lectures, we learned about supply and demand and how that gives rise to market equilibrium, and we learned how to use those concepts to make predictions about the market. And in this lecture, we're going to take the analysis a step further by introducing a concept known as price elasticity. To put it simply, price elasticity is a way for us to describe how price-sensitive consumers and producers in the market are. And as we're going to see, if we can know what the price elasticity of supply or demand are in a market, then that can help us to make more precise and more accurate predictions. And the man you see here on the right, he's someone we've already encountered in a previous lecture. It's Alfred Marshall, the 19th century British economist. He was the guy who was quoted as saying, "Economics is about mankind engaged in the ordinary business of life," or something to that effect. And as far as I'm aware, he was also the first to introduce the concept of elasticity in his 1890 textbook, Principles of Economics. Alright, so here are the learning outcomes for this lecture. By mastering this lesson, you should be able to explain the meaning of price elasticity of demand and price elasticity of supply, calculate the price elasticity of demand or supply between two price and quantity levels, identify examples of markets with elastic and inelastic supply and demand curves, discuss the factors that could affect supply or demand elasticity, and finally, use information about elasticity to make more precise predictions about how markets will respond to events. So let's dive right into it. The price elasticity of demand, as I already said, is going to be a measure of how sensitive consumers in a market are to price changes. Okay? And so if the quantity demanded is very sensitive to price changes, then we say that the demand is elastic. All right? And so here's an example of a demand curve that is elastic. So here's a very elastic demand curve. And as you can see, the slope of an elastic demand curve is going to be very shallow, because what this says is that for a small decrease in price, we're going to get a large change in quantity, right? And conversely, for a small increase in price, we're going to get a large decrease in quantity, okay? So an elastic demand curve is a demand curve that has a very shallow slope, and what that means is consumers are very sensitive to the price. Okay, on the other hand, if quantity demanded is not very sensitive to price changes, then we say that the demand is very inelastic. Okay, so here's an example of an inelastic demand curve. As you can see, the slope is very steep, because what that says is even for a very large change in price, the quantity doesn't change by very much, right? For a very large increase in price, quantity decreases by a little. For a large decrease in price, quantity increases by a little, okay? So an inelastic demand curve is a demand curve with a steep slope, and it suggests that the consumers are not very sensitive to prices. Now, if consumers are not sensitive to prices at all, meaning that quantity demanded doesn't respond to price changes, then we say that the demand is perfectly inelastic, okay? And a perfectly inelastic demand curve is going to look like a straight line that's vertical, okay? Because what this line says is that it doesn't matter what the price is, the quantity demanded is going to be the same, all right? So a perfectly inelastic demand curve is one where consumers are not sensitive to prices at all, and the demand curve is a straight vertical line. Okay, now what if instead of being completely unresponsive, consumers are somehow infinitely responsive to prices, all right? So if quantity demanded responds infinitely to price changes, meaning that a very small increase in price is going to drop demand to zero, and a very small decrease in price is going to explode the demand to infinity or to a very, very large number, then we say that demand is perfectly elastic, okay? And so a perfectly elastic demand curve looks like this. It looks like a straight horizontal line. because what that says is that, well, you can't really decrease prices because then demand is just going to fall to zero. And increasing prices puts the quantity to some way high number, right, all the way out there off the graph. And so visually it's going to look like just a straight horizontal line. All right, so straight horizontal line is a perfectly elastic demand curve, and it means that the quantity responds almost infinitely to even very small price changes. So now let's talk about how to calculate the price elasticity of demand. Formally speaking, the price elasticity of demand has to be calculated between 2 points on the demand curve, and it's equal to the percentage change in quantity divided by the percentage change in price. All right, so in other words, price elasticity is going to measure the percentage by which quantity demanded changes for each percent change in price. All right, so it's a percent on percent kind of measure. One thing to keep in mind is that there isn't going to be a single number for price elasticity for each demand curve. So it's not like a particular demand curve has one number for the price elasticity. It actually depends on the points that you're going to be calculating the elasticity between. All right, but between 2 points, generally speaking, a larger number for the price elasticity means a higher elasticity, and it means that the consumers are more price sensitive. Now let's do an example for how to calculate price elasticity of demand between 2 points. And for this example, we'll be calculating price elasticity of demand between point A and point B here on this demand curve. All right, so to do that, we're going to start with the definition of price elasticity of demand, which is this. All right, price elasticity of demand is going to be equal to the percent change in quantity demanded divided by the percent change in price. All right, so what we're going to do here is we're going to first calculate the percent change in quantity demanded between point A and point B. And then we're going to calculate the percent change in price between point A and point B. And then we're going to divide those two numbers to give us the price elasticity. All right, so we'll start by calculating percent change in quantity. And we're going to calculate percent change in quantity using this formula. The percent change in quantity is going to be equal to the difference in quantity between point A and point B divided by the midpoint of quantity between point A and point B, okay? And so formulaically, that's equal to QB minus QA divided by QA plus QB all over 2. Okay, so that's just the formulaic representation of the difference divided by the midpoint. Now, some of you might be thinking, isn't percent change equal to the difference divided by the initial value? So yes, that is the normal definition of a percent change. But the standard in most intro economics textbooks is to calculate percent changes using the difference divided by the midpoint instead of the initial value. And the reason for that is that way the percent change doesn't depend on whether we think of point A as the initial value or point B as the initial value, right? Because otherwise, the percent change is going to be different depending on whether we start at point A or we start at point B. So instead of having to make any assumptions about which one is the starting point, we just take the midpoint instead, okay? All right, so what's the difference in quantity between point A and point B? Well, the quantity at point B is 6, and the quantity at point A is 5, and so the difference is equal to 1. And what's the midpoint between point A and point B? Well, it's going to be 5.5, right? And so the difference divided by the midpoint is 1 divided by 5.5. And if you plug that into a calculator, you get 0.1818. All right, so 0.1818 is the percent change in quantity. Now let's calculate the percent change in price. Again, we use the formula of the percent change being equal to the difference divided by the midpoint. And here it is as a formula. All right, so what's the difference in price between point A and point B? Well, at point B, the price is 4, and at point A, the price is 5. So PB minus PA is minus 1, all right? And then what's the midpoint? The midpoint between the price at point A and point B is 4.5. All right, so the percent change in price is equal to minus 1, that's the difference, divided by 4.5, that's the midpoint, and plugging that into a calculator, we get minus 0.2222. All right, so this is the percent change in price between point A and point B. Okay, and the last step now is just to plug those numbers into the formula for price elasticity of demand. Price elasticity of demand is equal to 0.1818, that's the percent change in Q, divided by negative 0.2222, that's the percent change in P, and that gives us minus 0.8182. Okay, so minus 0.8182 is the price elasticity of demand for this demand curve as we go from point A to point B. And so in terms of what that number means, minus 0.8182, what that number says is that between points A and B, for every percentage increase in price, the quantity demanded is going to fall by 0.8182 percentage points. Okay, that's the interpretation of this number. And generally speaking, the price elasticity of demand is always going to be negative because price and quantity demanded move in opposite directions. All right, so now that we know what the price elasticity of demand is and how we can calculate it, let's talk about the things that determine the price elasticity of demand, all right? When is a demand curve going to be more elastic and when is it going to be less elastic? And the first thing we want to think about is the availability of close substitutes, all right? If a good has many close substitutes, then demand is going to be more elastic. But if a good is rather unique and therefore doesn't have many close substitutes, then demand will be less elastic. And the reason for this is that when a good has a lot of close substitutes, then when the price of that good rises, people can easily switch to one of the substitutes, right? And so an example of that could be, right, cornflakes breakfast cereal, right? There are lots of other breakfast cereals in the market to choose from. And so if the price of cornflakes rises, then a lot of people are going to switch from buying cornflakes into buying some other cereal. And so the quantity demanded of cornflakes is going to fall significantly, right? And so we can say that the demand for cornflakes is going to be very elastic and sensitive to price changes. All right, so here's an example of a good without many close substitutes, right? And that could be your internet service provider. If you live in my area of the woods, that would be Spectrum Cable, right? And the thing is that many people live in areas where there's only one major internet service provider. And so even if that provider raises prices, consumers don't really have too many options to switch to. And because of that, demand is not going to drop too much, right? Even if prices go up. And so we can say that the demand for internet services from your local service provider is going to be quite inelastic, all right? Now, one thing to keep in mind is that the availability of close substitutes depends a lot on your definition of the market. When we talked about cornflakes, we said that cornflakes has very elastic demand because there are a lot of other breakfast cereals to choose from, and so consumers can easily switch when the price of cornflakes goes up. But then if we consider the market for breakfast cereals as a whole, we see that there aren't as many close substitutes, right? There are some. People can choose to eat other things for breakfast, like oatmeal or pancakes or ham and eggs. But the substitutability between these different breakfast items isn't as high as the substitutability between cornflakes and other cereals, okay? And so the implication is that the demand for breakfast cereals as a whole is not going to be as elastic as the demand for cornflakes more specifically. And so to take this logic to a fairly extreme example, let's consider the market for eggs as a whole versus the market for brown eggs specifically. Now, eggs as a whole has very few close substitutes because there just aren't that many food products that do all the same things that eggs do. And so the demand for eggs is therefore going to be fairly inelastic. But now think about the market for brown eggs specifically, right? Brown eggs do have a very close substitute, and that's white eggs, right? And so the demand for brown eggs is going to be very elastic. In fact, the price of brown eggs can't really go much above or below the price of white eggs, because if the price of brown eggs goes above the price of white eggs, then no one's going to want to buy brown eggs, right? Everyone's going to switch to buying white eggs. And on the other hand, if the price of brown eggs falls below the price of white eggs, then there's going to be a huge increase in demand as everyone switches away from buying white eggs to buying brown eggs. And so we can say that the demand for brown eggs specifically is going to be very elastic and very sensitive to changes in the price of brown eggs specifically. Another thing that can affect the price elasticity of demand is the time period over which you're measuring the changes over. When measured over a short period of time, demand tends to be more inelastic, and when measured over a longer period of time, demand will appear to be more elastic. And for an example of this, take gasoline in the short run versus the long run, right? When gas prices change, people still have to do things like their daily commute. They still have to drive to go shopping and to visit friends and family. And so the demand for gasoline in the short run is probably going to be fairly inelastic and not that sensitive to prices because people still have to do the same amount of driving as they always did. But over time, if gas prices continue to rise, then people may actually start to adjust their habits and behaviors. People may decide to move closer to work to save on fuel costs. They might start shopping closer to home. They may even visit their friends and family less frequently, and they might take shorter trips for vacations that don't require driving as much. Right? They might even switch to fuel-saving electric vehicles. So over the long run, as people have time to change their habits and adjust to new prices, quantity demanded is going to be able to change much more than it can in the short run. And so because of this, demand tends to be more elastic in the long run and less elastic in the short run. Finally, since demand curves are always created by the utility maximizing decisions of consumers, it should go without saying that ultimately what really determines the elasticity of a demand curve is the preferences of the consumers themselves, right? And that's going to be affected by things like their tastes, their income, and other characteristics about the consumers. For an example of how consumer characteristics can affect the elasticity of a demand curve, let's think about groceries in a wealthy versus a poor neighborhood. In a wealthy neighborhood, consumers may not be as sensitive to the price of groceries because groceries form a pretty small proportion of their budget. And because of that, the demand for groceries in a wealthy neighborhood may be quite inelastic. On the other hand, in a poorer neighborhood, demand for groceries may be more elastic because the consumers there are more sensitive to prices. Okay, and there are no hard and fast rules about what characteristics of consumers lead to more or less elastic demand curves. And ultimately, how consumer characteristics affect the elasticity of demand is going to be an empirical question. So now let's talk about the price elasticity of supply. It's going to be very analogous to the price elasticity of demand, except that it just applies to the supply curve instead of applying to the demand curve. All right, the price elasticity of supply is simply a measure of how sensitive producers in the market are to changes in price. And so if the quantity supplied is very sensitive to price changes, then we say that the supply is elastic. Here's an example of a very elastic supply curve. It has a very shallow slope because what that's saying is that if price increases by a little bit, quantity will increase by a lot. All right. So the quantity supplied in an elastic supply curve is very sensitive to prices, and the slope is very shallow. What if quantity supplied is not very sensitive to price changes? Then we say that the supply curve is inelastic. And here's an example of an inelastic supply curve. It has a steep slope because what it's saying is that even for a very large increase in prices, quantity won't change by much. Okay, so an inelastic supply curve says that the quantity supplied is not very sensitive to price changes and it has a steep slope. Now, if quantity supply does not respond to price changes, so it's not responsive at all, then we say that supply is perfectly inelastic. And a perfectly inelastic supply curve is going to look like a vertical line, just like a perfectly inelastic demand curve looks like this. And what it's saying is that doesn't matter what the price is, the quantity supplied is still going to be the same. And finally, if the quantity supplied is infinitely responsive to price changes, right, meaning that a small decrease in price is going to drop the supply suddenly to zero, but a small increase in price is going to explode the quantity supplied, then we say that supply is perfectly elastic, all right? And a perfectly elastic supply curve looks like this, a straight horizontal line, just like a perfectly elastic demand curve looks like this. And what this is saying is that price can't really go far above or below this particular line. If it goes below, the quantity drops to zero. If it goes above, the quantity explodes somewhere off the graph, okay? Now let's do an example where we calculate price elasticity of supply between 2 points. Just like with demand, we can only measure it between 2 points. It's not a single number which defines a supply curve. And for the example, we'll be calculating price elasticity of supply between point A and point B over here, okay? So the price elasticity of supply is equal to the percentage change in quantity supplied divided by the percentage change in P. So it's basically the same definition as for the price elasticity of demand. The only difference is we're looking at quantity supplied instead of quantity demanded. To calculate the percent change in quantity, we take the difference and we divide it by the midpoint. All right, in point A, the quantity is 3. At point B, the quantity is 5, and so the difference is 2. The midpoint is 4, and so the difference divided by the midpoint is 2 divided by 4, which is equal to 0.5. Now to calculate the percentage change in price, we again take the difference in price and divide by the midpoint. The price at point B is 6. The price at point A is 4. So the difference is 2. And the midpoint between 6 and 4 is 5. So the midpoint is 5. And so the difference divided by the midpoint is 2 divided by 5, which gives us 0.4. Now we just plug these numbers into the definition of price elasticity. And so we get that the price elasticity of supply for this supply curve between points A and points B is 0.5 divided by 0.4, which gives us 1.25. And so what that's saying is that as we go from point A to point B, for each 1% increase in price, quantity supplied is increasing by 1.25%, okay? And in general, the price elasticity of the supply curve is going to be positive because price and quantity supplied move in the same direction. So what determines the elasticity of a supply curve? Well, it's hard to pin down any hard and fast rules. The elasticity of the supply curve is really going to depend on the details of the supply side of the market. And in particular, it's going to depend on the characteristics of the process by which suppliers bring the product to market. And specifically, it depends on the ability of suppliers to flexibly adjust quantities in response to price changes. So an example of a market that has an elastic supply curve is the market for Uber rides. Uber drivers maintain flexible hours, and they can quickly increase or decrease the amount they're willing to drive in response to price changes. Okay, and so the supply curve of Uber drivers on the road and their willingness to make rides is pretty flexible and can adjust quickly to price changes. An example of a market with an inelastic supply curve would be the market for gold, right? There's a very limited supply of gold in the world. It's very difficult to mine for more gold. And so the quantity is limited and hard to adjust. And therefore, when the prices of gold rise and fall, the quantity available remains fairly constant. Okay, and the second thing that supply elasticity can depend on is the time horizon. And just as with demand curves, supply curves tend to be more inelastic in the short run and more elastic in the long run. And the reason for this is the same, which is simply that in the long run, suppliers are able to make more adjustments in order to respond to price changes. And so let me give you an example of this. We can think about the market for housing in the long run versus the short run. Now in the short run, because housing takes a very long time to build and because land is quite limited, the supply curve of housing is going to be very inelastic in the short run. Even if prices change, the amount of housing available isn't going to change very much within a short time period. But over the long run, okay, more housing can be built. And in fact, certain types of less dense housing can be replaced with certain types of more dense housing, right? Single family homes can be replaced by condos or apartments or high rises, okay? And zoning laws can change. And so in the long run, the housing supply is able to respond to prices much more than it can in the short run. Now let me end the lecture with some examples of how knowing the elasticity of the supply or the demand curve can be very useful. First, knowing the elasticity of supply or demand can help us to understand real-world price patterns. And here's an example. As young urban professionals move to cities like New York and San Francisco, the demand for both housing and urban transportation, like taxis or Uber rides, went up because of the increasing population. And so the question is, why did the price of housing increase so much more than the price of taxi rides? And the answer is that it's because the supply of housing is less elastic. All right, and let's take a look at how that works. So I'm going to draw supply and demand in the market for housing and in the market for taxi rides, okay? And the key difference between supply and demand in these markets is that the supply curve in the housing market is very inelastic, and the supply curve in the market for taxi rides is very elastic because of technologies like Uber. And what happens when you get an influx of young urban professionals? The demand curve is going to increase, right? And it's going to increase for both the housing market and for the taxi market. But let's take a look at what happens to price and quantity in each of these markets. In the housing market, because the supply curve is very inelastic, when the demand curve went up, the prices went up by a lot, but quantity didn't go up by very much, right? And so prices went up by a lot in housing, but quantity, not so much. Now, how about in the taxi market? Demand curve increased a lot in the taxi market, just as with housing. But now, because the supply curve is very elastic, we can see that prices didn't go up by very much, but quantity increased by a lot, okay? And so knowing that the supply curve of housing is much more inelastic than the supply curve for taxi rides, we were able to explain why we saw these price patterns, these different price patterns in the housing market versus the taxi market in response to a demand shock. A second thing that knowing elasticity can help us do is to make more precise predictions about the market. So here's an example. Climatologists are predicting a drought next year that will drastically reduce the supply of coffee. What will happen to the price and quantity traded of coffee? Now, this is the kind of question that we were looking at last lecture, and if you'll remember, we can really only say something quite limited. We can say that the price is going to increase and the quantity is going to decrease, but we can't say much more than that. But what if we also knew that the demand for coffee was very inelastic, right? Those coffee drinkers need their coffee and they're willing to pay any price to get it.
Coffee time!
What more would you be able to say? So let's draw a supply and a demand curve in the market for coffee with the feature that the demand curve is going to be very inelastic. All right, now what does the drought do? The drought reduces the supply curve. And now if we look at what happens to price and quantity, we see that because of the very inelastic demand curve, the price went up by a lot, but quantity didn't go down by very much. Okay, so our answer is that price increases by a lot because of the drought, but quantity decreases by only a little. So as you can see, if we didn't know the elasticity of the demand curve, we wouldn't be able to say much more than this. Price is probably going to increase and quantity is probably going to decrease, but we don't really know by how much. If we knew that the demand curve is very inelastic, then we can predict something more. We can predict that price is going to increase by a large amount and quantity will decrease by a small amount. Okay, so knowing the elasticity of the supply and the demand curves can help us make better predictions. Last but not least, knowing the elasticity of the demand curve can actually help firms calculate how much their revenues would change in response to a price change. All right. Now, the revenue that a firm makes from a product is equal to the price of a product times the number of units sold, which means that the percent change in revenue when things change is equal to the percent change in price plus the percent change in quantity sold, right? And since elasticity relates how percent change in quantity is affected by the percent change in prices, knowing the elasticity can help you calculate the percent change in revenue. So let's take a look at how this works. Right, let's say the price elasticity of demand for a firm is currently -2. What that means is that for every 1% increase in price, there's going to be a 2% decrease in revenue, right? And so for a 1% increase in price, you get a +1% change in price and a -2% change in quantity. And so that means a 1% increase in price is going to lead to a 1% decrease in revenue for this firm. But now let's suppose there's another firm that's facing a price elasticity of demand, which is -0.5. And what that means is that a 1% increase in price for this firm is only going to lead to a 0.5% decrease in revenue. So the percent change in price is +1%. The percent change in quantity is -0.5%. And so this 1% increase in price actually leads to a 0.5% increase in revenue. Okay, and so for this firm, they're actually better off with the price increase. And so what that means is that, generally speaking, firms that are facing an inelastic demand curve will generally want to charge higher prices, and firms that are facing an elastic demand curve generally want to charge lower prices. Now, so far we have been treating firms as price takers, meaning they can't really control the price. But of course, that's an assumption about perfectly competitive markets. In real life, most firms have some degree of influence over the price that they're able to charge. And so in real life, firms do want to know what the elasticity of the demand curve that they're facing is, because that's going to tell them whether increasing prices is going to raise revenues or it's going to decrease revenues because of the decrease in quantity. All right, and so the elasticity of a demand curve is something that firms in real life are very interested in knowing. So that's it for today's lecture. Here's a quick review. The price elasticity of demand or supply measures the percent by which quantity demanded or supplied changes for each percent increase in price. Price elasticity is measured between 2 points. There isn't a single number for price elasticity that describes a supply or a demand curve. In order to calculate price elasticity, we first calculate the percentage change in quantity between the 2 points, and then we divide by the percentage change in price. And we calculate percent change by taking the difference and dividing by the midpoint. The elasticity of demand is affected by a number of things, primarily the availability of close substitutes, which depends on market definition, the time horizon over which we're measuring the changes, and consumer preferences. The elasticity of the supply curve is affected by the characteristics of the supply process itself, in particular the ability for suppliers to flexibly adjust the quantity. And it also depends on the time horizon, just like with demand curves. And finally, the purpose for knowing the elasticity of supply and demand is that by knowing the elasticities, That can help us understand the real-world price patterns that we observe. It can help us make better predictions about market outcomes, and it can help us calculate the effect of price changes on revenues. Alright, so that's it for today. Thank you for sticking around to the end, and I'll see you guys next time.